My name is Ed Rothberg. I'm the CEO at Garebe Optimization. One major new feature in our new release is a new bilinear mixed-integer programming solver. This allows us to handle problems with non-convex quadratic objectives and non-convex quadratic constraints. Non-convex quadratic constraints arise in a number of different problems. One important example is pooling problems, which are quite common in continuous manufacturing.
Hello, and thank you for attending this virtual presentation of my near-miss research. I'm disappointed that we didn't get together in person in Denver to be able to discuss this research, but hopefully this virtual conference will help with the knowledge sharing. The first thing that I would like to do is thank my collaborators, Kathy Tinsley at Georgetown University, Peter Madsen at Brigham Young University, and Matt Cronin at George Mason University. All three of these collaborators have contributed greatly to this research that I'm going to present here, and I really appreciate all the collaboration over the years with them. In my presentation, I'm going to start out by talking about the motivation for the research, and in particular, what we mean by a near miss. Then I will talk about the results of 3 areas of application that we've worked on, one from space missions, one from hurricane evacuations, and one from commercial aviation. We've been working on this research for more than 15 years, so we have a lot of studies, some field studies and some experimental studies. In this case, I chose 3 field studies because of the analytics focus of this event. I wanted to provide ones that had data that we analyzed as opposed to our experimental data. And then I will wrap up with conclusions and give you a few thoughts of what some of this risk research is relevant to the current COVID-19 crisis. So starting with the motivation for our near-miss research, it goes back to the early 1990s. In the early 1990s, I saw Dr. Elizabeth Paté-Cornell. I was a grad student at the University of Virginia, and she came to visit and gave a presentation on her research of the risk analysis of the tiles of the space shuttle for NASA. Her work was collaborative with Paul Fischbeck, who at the time was a grad student, who has now since had a very successful career at Carnegie Mellon. And both Elizabeth and Paul were finalists for the Edelman Award for this research in 1993. And basically what they did was they told NASA that the debris was a problem. They drew them a map of the orbiter. They showed them where sensitive portions of the orbiter that are hit with debris could be catastrophic. And when I saw this risk analysis that they'd done, I was very motivated, and I applied to Stanford and became a grad student of Elizabeth Paté-Cornell's. Studied for many years with her, very enjoyable experience, graduated, ended up at Georgetown University, and I was sitting in my office at Georgetown University in 2003 when we lost the Space Shuttle Columbia. And we lost the Space Shuttle Columbia for a reason that she had identified. It was in her models. She was concerned about the debris coming off of the external tank. She warned them if a big enough piece of debris hit a sensitive enough portion of the orbiter, it could be catastrophic. When she turned this research in to NASA in the early 1990s, they were concerned about it. And we didn't need a better risk model. It wasn't any challenge or problem with the model itself. It was what happened to the people between the early 90s when she did this work and 2003 when we lost the Space Shuttle Columbia. And what we then focused on was all the near misses that happened because that same piece of foam had actually fallen off 30 times before, but it just had not hit a sensitive enough portion of the orbiter. And in effect, they were drawing balls out of an urn. Fortunately, from their perspective, there were very few black balls and a lot of white balls, but they were really just getting lucky. It was just a matter of time until a big enough piece of foam hit a sensitive enough portion of the orbiter, and that's what happened on Columbia. And so what we set out to examine was how these near misses, all of these events from when they worried about it and asked her to do this research till they lost Columbia, what was the perception? How were all these events influencing their decision making? And then this ended up becoming one of our publications in management science in 2008. And at the end of this presentation, I have more of the citations, and this is some of the work that I'm going to talk about. In terms of risk preparedness and organizational learning, some of the things that many people have contributed in this research area is that at the individual level, we know that people's own experiences influence how they interpret any given statistically generated risk in order to try to understand how the risk, what that risk means for them personally. So you can know that you are a high risk or a medium risk or a low risk, but it's still your influence and your interpretation of it. And we also realize that when people perceive the risk of some hazard event to be low, they are unlikely to engage in risk mitigation activities. And so while some people are very concerned about potentially catching the COVID-19 virus, and they may be sheltering in place and wearing masks when they go out, and gloves and hand sanitizing, other people see it to be a lower event and they are more or less going about their business, or they may be protesting at government capitals without distance between them and without masks. And so there's some perception of the risk that people interpret. We've also looked at some of this research at the organizational level. And in particular, that's my colleague Peter Mattson is an expert in organizational learning, and that's what he's brought a lot of expertise to this research over the years. And we find that success tends to breed complacency because decision makers institutionalize established practices and reduce search activities aimed at identifying further system improvements. So when we have failures, people change. But when we have success, people don't. People think that the processes are working. The problem with the near misses is that the near misses will act as a success or be interpreted as a success, but it really isn't. It really is, but for luck, they didn't have a failure. And so that's where our definition of near miss, it's an event that had a non-trivial probability of ending badly, but by chance did not. And so in particular, what is salient about the event is the positive outcome in the face of hazard. So people realized that they were fine the last time, or the system worked. And so while they took a risk, they got the good positive outcome. And this is also throughout this presentation, I'll refer back to outcome bias. Outcome bias is an important contributor to how people are interpreting near misses, because they get the good outcome, and so there's no incentive for organizations to try to change and to try to learn. But what they don't realize is that there was some non-trivial probability of it ending badly. If that big piece of foam had hit a sensitive enough portion of the orbiter the 30 times before when it fell off, they would have had a different outcome earlier, rather than assuming that the debris was less of a problem and that they understood what was going on. So we also included a quote from March, Sproul, and Tamuz, who says, every time a pilot avoids a collision, the event provides evidence both of the threat of a collision and for its irrelevance. It is not clear whether the organization came close to a disaster or that the disaster was avoided. And that's really the challenge with near misses, is you get the positive outcome, but you don't know how close you were potentially to a disaster. And so it's not clear whether the organization should say, oh no, these planes almost collided, that could have been very bad, or to see that our system works so that our planes won't collide, even if they get very close to each other. And sometimes we don't really know until we have the bad outcome. And so what we encourage in this research is knowledge and awareness and understanding of these kinds of events so that you explore them further and that you don't just treat them as success. In some of our research, we show that it has a lot to do with how obvious the cues are of danger. So that near misses embedded with cues of obvious danger invoke feelings of caution and thoughts of system vulnerability, which will counter this basic outcome bias effect and encourage greater scrutiny of near misses. So if something happens and you're scared enough, or if this near collision is scary enough, people will change their behavior. But too often people take chances and they get away with it, and they don't have these obvious feelings or obvious cues of danger, in which case they don't. And then they continue to take risks, or in some cases they take even more risks. What this chart is showing you, so the first case study I'm going to talk a little bit about is some of the research we did in space missions. And so what this chart is showing you is it is showing you in-flight anomalies reported for each NASA space mission during the lifetime of the program. And so it would make sense that it would decline over time, that we would learn and that we would get better, and so that we would have fewer in-flight anomalies. But we have to remember that this is a system that has millions of parts. The space shuttle had millions of parts. And you can see that there's two gaps in my chart. The first gap is when we lost the Space Shuttle Challenger. And the second gap is when we lost the Space Shuttle Columbia. And the part that is particularly concerning to me is how low these reported in-flight anomalies got right before the Space Shuttle Columbia. So one conclusion is that we've been doing this long enough, we understand what's going on. Or another possible conclusion from this data is that we weren't sufficiently paying enough attention to these potential problems. And unfortunately, it was the latter. I actually had the opportunity to present this graph at Marshall Space Flight Center a number of years ago, and I thought I would just put this graph up, mention what it showed, show the trend lines, and move on. But instead, we actually spent 45 minutes talking about this graph. And in particular, what we were talking about was the culture at NASA at this very low point, where you were encouraged to handle problems on your own and to not raise concerns, because what we were really focusing on as a nation, and what NASA was pushed towards, was completing the assembly of the space station. And so any problems that the space shuttle was having would delay the space station assembly. And so there was a lot of pressure in this point right before Columbia to not focus on these potential problems, because we're so focused on space station completion. And we can see that after big events, the focus and the learning goes up. But then even when we retired the space shuttle program, we were already coming down in terms of our reporting and our vigilance. So hopefully that's interesting data. What we also did, the study that I'm actually going to report on, is a study that we did on unmanned NASA missions. And what we had was we had a proprietary set of incident surprise anomaly reports from the Jet Propulsion Lab. And it was for virtually all space missions managed by JPL between 1989 and 2010. It was 30 missions. And the procedures dictated that an ISA report shall be written on all post-launch incidents, real or suspected, which indicate an anomaly in hardware, software, sequencing, test operations, procedures, etc. So any problem you had, you needed to write it down. That's what their guidance was. They had written procedures telling them to do that. And so we considered these deviations, these ISAs from expected performance, to be near misses. Because these weren't ones that killed missions or caused catastrophic failure, but these were incident surprise and anomalies. And so we considered them to be near misses. And we did several different things to analyze this set of data that we had access to. Because the pattern in near misses may change over mission phase, we segmented the ISAs for each mission by month for a total sample of 2,325 mission months for the 30 missions. Our dependent variable was near miss reports, a count of the number of ISAs reported by month for each JPL mission. And then we had a number of independent variables. We had mission cost, which was the total development cost of each mission in constant $2010. We had mission complexity, which was the number of formal scientific objectives a mission was designed to complete. We had mission visibility, which was a count of the number of articles in major news outlets devoted to a given mission published within 1 week before the launch to 1 week after the launch. And we had a low safety climate indicator. And this indicator variable was a 1 if the mission was planned during NASA's faster, better, cheaper era, which for people who have studied NASA or are familiar with it, it was a lot of focus and a lot of culture on getting lots of missions. They were saying it was okay to accept risk. We're going to do things faster, better, cheaper. And so we were saying that that was the lower safety climate. And then the indicator variable was a 0 for all our missions that were planned outside of this faster, better, cheaper era. We had a number of control variables. We had an indicator variable if JPL was the primary mission manager, and a 0 in our indicator variable if the JPL was managing only a subcomponent of the mission, with the assumption that more ISAs would be reported for missions that were managed by JPL since it was JPL's system. The number of months since NASA had experienced a significant accident, such as the loss of Columbia. And so we're have this premise or have this belief that more focus on safety would result in more reports. We also controlled for the mass of each spacecraft in metric tons, the number of different science instruments present. In both of those cases, bigger missions, more complex missions should have more reports. We also had an indicator variable if the spacecraft had already completed its primary mission, because one of the things that we see is that many missions go beyond their primary mission. They get extended missions, but the focus and the attention on the mission once it's in an extended phase is certainly a lot less. We also had indicator variable if the spacecraft was trying to enter orbit around a planet or other object during that given month, or if it was attempting to land on a planet or other object during that given month, also because those are very complex maneuvers. So I'm just going to present the results. Again, the references for these papers are at the end of this presentation. If you want to see the regression models, please, I refer you to the paper. Given the nature and format of this talk, I'm not going to show you numbers and p-values, but these are all published papers, and so you can go see them and explore them yourself. But I'm just going to tell you what the results were. And what we found was we found a greater number of near misses were reported for missions managed by JPL for more massive spacecraft and during months in which the spacecraft enters into orbit or lands on a planet or other object. We found that fewer near misses were reported for missions during months after its primary mission were completed. We found that fewer near misses were reported for missions occurring during NASA's faster, better, cheaper era. So absolutely, lower focus on safety, more focus on taking risks, and having this risk culture resulted in less reports. We also found more near misses are reported for more costly, more highly externally visible, and more complex missions. And so as missions had more focus and more attention around their launches, they were more highly visible, people were paying more attention to near misses, and they did have more reports. And we also found an interesting interaction that high organization safety climates, meaning those outside of the faster, better, cheaper era, and project significance interact, such that the near miss reporting is consistently high when the organizational safety climate was high, but when it was low, like it was in the faster, better, cheaper era, near miss reporting was more sensitive to project significance. And so what we concluded from this research was a number of factors that you really should pay attention to when people need to report events. And that's one of the things that's interesting about near misses is that we need to recognize them and we want to learn from them. So we need to realize that this was something that is an opportunity for learning and realize that this is something that we should be paying attention to. And what we found were all of these times when people were paying more or less attention to them. And it was when they were more highly visible, and it was when you had a stronger safety climate. And so that got people to pay more attention and recognize these events. And so that was interesting learning and important for cultures where recording these are important. So my second case study, I'm going to talk about hurricane evacuation behaviors. And so what data we used in this study is, and there are also, again, the references are at the end, but there are numerous studies in all of these papers, but I focused on the ones that had data because I thought that would be the most interesting to this audience. And what we had available to us was we had a field survey of 1,000 households in coastal counties of Louisiana and Texas who experienced Hurricane Lily. And we did not conduct this survey. This survey was conducted by Michael Lindell and several of his colleagues at the Hazard Reduction and Recovery Center at Texas A&M. And if you're familiar with hurricane evacuation research, Michael Lindell and his colleagues at the Hazard Reduction and Recovery Center are some of the best people at surveying people and for evacuation behaviors and understanding it. And so we had 507 usable surveys were returned for a response rate of 50.7%, which exceeded similar hurricane studies. And they had actually done this, they'd done and collected their survey for their own research, and it was only after the fact that we asked them if we could also re-examine it, which they were happy to share with us. And so what they had asked, so we had no input on what the original questions were, but conveniently they had asked a question that asked about whether or not they had previous experience with an unnecessary evacuation. And it was on a 1 to 5 scale where 1 was not at all and 5 was very great extent. And so we considered that in this research to be prior near-miss experience. So if you had had previous experience with an unnecessary evacuation, that's what we wanted to find out, how that would then influence your future evacuation behaviors. And so we tested whether or not this prior near-miss experience reduced evacuation behavior beyond what is due to social cues, household proximity to coasts and waterways, and observance of the storm conditions, high wind, rain, and flooding, which were other variables that they did ask in the survey, and which have been shown to influence people's evacuation behaviors. Again, I will refer you to the papers and the references at the end of this presentation for the actual regression models. But what we found was that geographic proximity, social cues, and seeing storm conditions all had a positive influence on that evacuation behavior, which is consistent with all of the literature that we've seen in the 40+ years that people have been studying why people evacuate. And but we still saw that prior near-miss experience, having evacuated when later deemed unnecessary, had a negative influence. And so what we talk about in this paper, and what builds on some of the introduction definitions that I was talking about, is that not all people experience near misses the same. And if you do have these strong cues of vulnerability, of potential catastrophe nearly happening, then people will take more protective actions. But what this research has really shined a light on is that there's this other category of near-miss experience where people feel resilient. They didn't have a problem, they evacuated, they later deemed it unnecessary, and so that causes them to take less protective action in the face of future storms. And that was an important distinction that came out in many of our papers, is this idea that we really need to shine a light on these near misses that embolden people to take more risks in the future. So moving on to my third set of data that we looked at. This was commercial airline safety data. And what we did here is we had archival data from US commercial aviation industry from 1990 to 2007 for the large certified air carriers, those who had revenues of $20 million or more. As I'm going to explain some of the variables that we looked at in this data set, due to lags required to construct some of the variables, we excluded any airline that operated for less than 3 years. Our final data set included 64 airlines, and we looked at things in quarters, and so we had 2,955 quarterly observations. The data we collected quarterly airline operations data from the Department of Transportation's Bureau of Transportation Statistics, Air Carrier Statistics, and Air Carrier Financial Reports. We also gathered airline accidents from the US NTSB Aviation Accident Database. Our airline incidents, or our near misses, came from the FAA's Accident Incident Data System. And then what's going to be important is what we were looking at, or what is going to be an important finding here, is the near misses that people pay attention to versus the near misses that they're not really paying attention to. And so one of the things that we also used was the causal model for air transport safety, which is the CATS model, which was developed by the Netherlands Ministry of Transport. And we use this to categorize accidents and incidents in a way that I'm going to explain again in a moment. So the purpose of our study, we were trying to examine organizational learning from experience with near misses and accidents, where we assume an organization has learned to the extent that future accident rates decline when we control for other reasons that accident rates could be declining. And so in order to do that, we treated our dependent variable with the number of accidents experienced by an airline in a given quarter. And we use the NTSB definition of an accident, which is an event that takes place during the operation of an aircraft that causes the death or serious injury of a person, or causes structural failure or significant structural damage to the aircraft. Our independent variables, we had prior accidents, which was counts of prior accidents over 3 years prior to the current quarter for a given airline. We also had, and this is where the CATS models were relevant, we had whether this incident, this near miss, was an identified scenario or not an identified scenario. And so these CATS models, what they had done was they developed a set of event sequence diagrams to focus on and study various different incidents to learn from. And so we looked at whether these incidents were associated with CATS identified event sequence diagrams, or whether they were not. And so this was used to test whether airlines learn from events that they recognize and study as potential failure modes, where CATS was our proxy for these were the events that people are recognizing and studying as failure modes, versus those events that are not a focus. And so this was our proxy for focal events. The other independent variables were whether this incident, this near miss, was from a similar category as had a major accident previously, or whether this was from a category that had never had a major accident. So we also had counts of incidents separated by whether the category of the event had resulted in at least one major accident in our data set, or was this something that had never resulted in a major accident. We had many control variables, year fixed effects to control for exogenous changes over time in the airline industry, either from regulatory or technological changes. We had accidents experienced by other airlines over the previous 3 years to control for vicarious learning across the airline industry. We had number of airline departures in a given quarter to control for airline size, things that have more departures, more chances for something to go wrong. We also included control variable for airlines' average stage length in miles to control for more risk from longer flights. The longer a flight, more potential for something to go wrong. We also had a ratio of airline assets to departures to control for airline capitalization. We also had airline operating margin to control for the effects of profitability. And we had an indicator variable for whether or not an airline was undergoing bankruptcy reorganization in a given quarter. So would any of the capitalization, profitability, or bankruptcy, how would any of these financial factors also be potentially influencing accidents? So again, similar to my 2 previous studies, if you want to see the actual regression models, I refer you to the papers. But I'm just presenting the results. What we found were that the airlines learned to improve their safety performance in response to their own accidents and accidents experienced by other airlines. So accidents, big events, airlines learn, we change procedures, things happen. We also see that airlines can learn from some types of near misses, that there are many people in the airline organization who are studying all kinds of incidents and studying unstable approaches and are studying runway incursions, and that they're trying to learn from these. And so if these incidents were the same category of an event that had at other times resulted in a major accident, that was associated with a clear sign of danger. But we were not learning from near misses that were not obvious signs of danger or were not things that people were paying attention to. And so what we concluded from this research was that the capacity of airlines to use near miss experiences to improve safety, while it's been very good and they are studying it and they are making improvements, we think it could actually be better. And how we think it could be better is that we need to still keep learning even from the obviously not threatening or the not obviously threatening near misses. And also, again, one of our key messages from much of this research is that in order to have these data sets for people to be able to study, we need really good reporting. And if the challenge is recognizing a near miss, we need to broaden the reporting. And so we want to make sure that more and more events are captured by flight crews, ground crews, air traffic controllers, maintenance personnel, and other stakeholders. Because the more we can capture the data, the more the potential exists to find things in the data. But if we're not recognizing them as near misses, we're seeing them as a success, they're not obviously threatening, they're not getting recorded, then there's less learning that can come from that. So that feeds into my conclusions. And so my conclusions are that people are naturally prone to outcome bias. This is a general tendency to overweight observed outcomes and underweight the role of chance in producing said outcomes. And so we see successes and we don't dive in further. Very, very few people ever say, hey, but did we just get lucky? People see that it's a success. We got the outcome we wanted. Clearly, that was what we needed to get. And underweight that in many cases, it really was just a positive draw out of that urn. Many of the NASA reports following Challenger and Columbia refer to normalization of deviance. And this is when a risky behavior becomes commonplace over time because there are no apparent negative consequences. And that is certainly a concern, and that is why we need to recognize these near misses. That if we normalize and allow these deviants, these additional risky behaviors to continue, then we can't learn from them. People forget that we even need to. And that was one of the most interesting awakening moments that I saw when I reflected back on the evolution of the space shuttle from the time in the early 90s when NASA asked Professor Pate Cornell and Paul Fischbeck to study this problem, was that over time they worried less and less about it. They thought they understood it. The space shuttles weren't coming back with obvious burn marks. And so with these no apparent negative consequences, they continued this risky behavior over time. What we realize is that learning requires that people notice a danger associated with non-accidents that could produce accidents under different conditions. And that's exactly what didn't happen with the space shuttles. And where people recognize that our incident databases, that these are going to be our powerful sources for understanding and changing, and we need the data so that we can use all these great analytic tools to find patterns in the data and to find these relationships. But the relationships and the patterns are only going to be as good as the data that gets in the database. And so what we really need is we need to make sure that we have an understanding when near misses will be recognized as something different from successes and logged into a system. And then understanding when near misses will be attended to because they activate thoughts of feelings and danger, which can motivate learning. And when all of those things aren't happening, we need to change the system, like we talked about with the faster, better, cheaper missions and the unmanned missions in the JPL data set, was that focusing on safety or focusing on visibility, more things got logged, more things got recognized. All right, with just a few minutes left, I wanted to have just a few thoughts. As a professor and with expertise in risk analysis, I'm getting lots of questions about some of my thoughts on this COVID-19. I don't know, I haven't studied enough of these areas to know whether there are really the near miss events there. But what we for sure have seen is increased risk taking in many of these areas that have contributed to this virus spread. Over time, without people being concerned. And so we certainly have more increased risk taking, and you get away with it, and it seems to work, and so we continue to do it. We've always been okay before. This is the US, we can make things work. And a couple of the areas where it for sure seems like we were for decades taking more risk, with our very lean supply chains and our inventories for personal protective equipment, our reliance on China to produce all of these materials, or the majority of these materials, and our supply chains being leaner and leaner. Also with hospital consolidations, hospitals have been underfunded, and in order to be profitable, more and more of them have consolidated. And one of the things that we see in many of these areas is, in like particular Washington, D.C., where I am, is people are actually reopening hospitals that they had closed down years ago so that they could get more capacity. And so taking increased risk, squeezing more of the slack out of the system. Certainly overconfidence of our US health officials. If we look at the quotes from February, late January, early February, even early March, we think we can handle this. People are not recognizing the risk based on the fact that we've always been okay before. We've handled it before. We handled Ebola. If we could handle Ebola with the CDC, we can certainly handle this. And then with these massive wave of unemployment, we see huge problems. I think they're mostly overcoming them, and they're trying to overcome them very quickly. But antiquated state unemployment systems, we've had such a healthy economy and such low unemployment for recent history that we really have increased our risk of having these solid systems that could do this. And so again, I'm not an expert in any of these 4 areas, but from what I've seen, that these are 4 areas that we've had challenges with this COVID-19 crisis, all of which were over time, increasingly, decisions were made to accept more risk in all of these various different situations. And because we never had a problem before, we continued. And so we continued to make things leaner, consolidated, antiquated, because we'd always been fine before. And now with this whole problem, the whole catastrophe, we're realizing that maybe we allowed too much risk to grow into these systems. And again, I'm not sure, I don't know, and can't point to the near misses in it, but it is sort of this overconfidence of very strong, good outcomes from taking risk that allow it to continue. And so with that, I will conclude and leave up the publications that we've done over the last 10 to 15 years in many different fields. You can see that this is where, if you're interested in the regression models, I will refer you back to the papers themselves. So thank you.